Welcome to this course on industrial automation. Comes are after successful completion of this course, student will be in position to first is understand process control, PLC architecture and interfacing. Second, they will gain the knowledge and they will be in a position to develop PLC ladder logic for industrial applications. And the third, they will be in a position to design automation system for mainly industrial application. So here all these applications are related to industry only, and that is why the name of the subject, that is industrial automation. We'll go through the syllabus. So in the syllabus, the first part covers process control and automation, basic concepts of automation, analog digital control, then architecture of industrial automation, advantages, limitation, and some industrial revolution. That is, then this is the main content of the module 1. Module 2 covers sensors, transmitters, and the signal conditioning. Few basic sensors are covered here, where mainly we will be targeting actuators and the controller part. Module 4, it is all about PLC. Module 5, we will be talking about the SCADA, then DCS, that is distributed control system, and the unit number 6 will cover the industrial communication and human machine interface. So these are the few applications where you can find the use of automation. This is the second example of cold drink filling system. Here we are using, you can say, this is the sensor, this is another sensor, two sensors are used here. This is PLC, that is programmable logic controller. So we'll try to understand this process control and automation. So we'll just go through one small video and you will understand the importance of the process control and automation.
So industrial automation is all about large-scale processes with a high degree of quality and consistent accuracy. When we need to manufacture a product on a large scale with consistent quality, at the same time, we need to hire an engineering firm to design an automatic manufacturing process for our business or factory. When we're going to manufacture a product, there's always a start line and a finish line. The start line is where the raw materials enter into the factory, and the finish line is where the final product is manufactured and ready to be shipped. Between the start and finish lines, there's a process that turns the raw materials into that final finished product. So here, I have a process. The raw materials can be considered as the input for this process, and the final product can be considered as the output, or as the final outcome. Now, just as the process of turning on and off a light, this process of manufacturing a product in a factory can happen either manually or automatically. For the manual process, we can hire a few workers to do the job. But with the automatic way, we can put a system in place that is able to take care of the whole manufacturing process, or at least some parts of it, automatically. For instance, let's say that you're going to start a cupcake business and you want to make your own cupcakes. To make the cupcakes, you'll need a manufacturing process, where all the necessary ingredients come in as the input and a delicious cupcake comes out as the output. Now, at the beginning of your business, when you're on a tight budget and of course have fewer customers, you can hire one or more workers and train them to make the cupcakes based on your recipes. With this limited manual manufacturing process in place, you may be able to make the cupcakes at a reasonable speed and with consistent quality. But as your business grows, trying to make more cupcakes manually with a high consistent quality will be very difficult. Why? Because humans make mistakes. For instance, if one of your coworkers adds more of one ingredient, that batch of cupcakes won't have the same quality as the rest of the cupcakes. And if this happens often, your business will start losing customers and eventually losing money. Now, what should you do to solve this problem? To solve this problem, you'll need to hire an engineering firm to help you turn this manual cupcake manufacturing process into an automatic process. With the new automatic manufacturing process, you're going to have fewer employees and more machinery. This means with the new system in place, your machines are going to take care of most of the jobs that were previously done by the workers, and they're going to do it fast, hassle-free, and accurate. So with the automatic process, you're able to make more cupcakes with the same constant high quality, and this helps your business grow faster. The same principles apply to other industries.
Then this is the arrangement in every industry, that this is the plant is nothing but the process or the operation to be performed in the plant. And to complete this operation or the process automatically, we have to use some sensors and actuators. So those devices we are calling as a field instrument. Field instrument may be sensor or maybe actuator. Actuator is nothing but the motor, and this field instrument, that is mainly sensor, will give output to the control system, and the control system will be having hardware part as well as software part. Software is nothing but the PLC ladder programming or functional block diagram or any one technique used for programming it, that we are calling as a software control, and hardware control is nothing but the PLC hardware. So combination of hardware and software, it will build one complete control system. Whatever output is produced by control system, that will be given back to the again field instrument operation of plant. So it is actually bidirectional operation. That is why it is shown by bidirectional arrow. So sensor will produce the output and it will give to the control system this way. It will execute the program, and then whatever output is produced, that is given back to the field instrument, and field instrument control the operation of the plant. So we'll see one more animation to understand more about the industrial automation.
Sensors are the figurative eyes and ears of a control system. In general, if you want to control it, you must sense it. Because the controls engineer is often called on to specify sensors and deal with sensing problems, sooner or later we will all get more than enough familiarity with them. In this video, we are going to familiarize you with the sorts of sensors that we frequently use in industrial equipment. We intend this to be an introductory video for a new engineer just getting started, or for anyone on the electrical end of things. So in this exploration, we will look at two broad categories of sensors: digital sensors that return on-off signals, and analog sensors that return a range of values. Our first stop is digital sensors. These are by far the most commonly used sensors in the industrial world. So, what is a digital or binary sensor? In theoretical terms, we're referring to something that returns one or more bits of information per sensor. Initially, they were simple: a contact that touched another contact when something got where it was supposed to stop. In those old machines, this often meant 110 volts exposed for the operator to touch, or passing through the machine frame. Unsafe under any condition, and probably illegal in today's safety-conscious world. Later, these became a switch that flipped when something got to a position. These are referred to as limit switches, and are still in use. We use these sorts of sensors for anything that we divide into two states: on and off, true and false, is and isn't. For example, in position, full, empty, power on, and running. Let's look at a few examples of these kinds of sensors. First, as mentioned before, mechanical switches of various kinds are still around. Limit switches are still used in ugly, dirty environments thanks to their armor-plated construction. One big reason they have become less popular over the years is that they're huge compared to many of the other sensors available. Proximity sensors, very often called proxies, are used for detecting close metal objects using magnetic fields. In many environments, these have replaced limit switches in position sensing applications. Optical sensors have a much longer range than proximity sensors, but they are susceptible to dirt and other environmental and mechanical issues because they use light for sensing. We often use them where we are not picky about exactly where the target is, but we need to know it is there, like boxes on a conveyor, where we don't care where on the conveyor it is, just that it's passing by. Capacitive proximity sensors are like a proximity sensor, but for detecting non-conductive materials. They are very sensitive to contamination, and historically have not been very dependable. Ultrasonic proximity detectors detect solid objects using high-frequency sound, but are very susceptible to environmental conditions and dirt. We don't use them often, but they can solve sensing problems nothing else can. An auxiliary contact is a part of a relay. These tell us when whatever is controlling the relay has turned it on or off. A push button senses the operator's action. For now, that's all we'll say about digital sensors. Most controls are still designed around on-off signals, so these are the bread and butter of a control engineer's life. At one time, cars had no fuel gauge, and you had to have a reserve tank, a gas can, so that when you ran out, you could get to a fuel station. Now, cars all have fuel gauges, and we will next look at the sensors that make that possible, along with many other measurements that automation requires. An analog sensor is one that converts a variable physical quantity into a signal that the control system can understand, a voltage or current. By physical quantity, we mean temperature, pressure, humidity, distance, and speed, among others. There is a general category of sensor for each of these. Some sensors combine quantities, like temperature and humidity, or distance and speed, into a single instrument generating two signals. There are a few general categories of signals generated by these devices. For temperature sensing, the devices themselves produce either millivolt range signals, in the case of thermocouples, or variable resistances, in the case of resistance temperature detectors, or RTDs. Because of their higher accuracy and repeatability, RTDs are generally a better sensing element when we can use them. PLCs have cards that are specifically designed to handle both of these kinds of devices. The rest of the signal categories are converted locally into a more generally understood form of signal, either voltage or current, before being connected to the control system. If the temperature signals have to travel very far to the control system, we usually convert them like this also. The most commonly used standard today is the 4 to 20 milliamp signal because of noise immunity and other characteristics. And every type of analog sensor I have mentioned can generally be purchased in that type of output. We have just taken a whirlwind tour of the primary sensors used in almost every industrial control system. With these sensors, we sense everything from which buttons the operator pushes, to the height of liquid in a tank, to the pressure and temperature of steam in a boiler. These sensors and a few others, with their signals processed by hardware and software, control the industrial...
Topic is the architecture of the elements or the automation pyramid. Whenever we talk about the industrial automation, it is very important to understand this pyramid. So description of this pyramid, we'll try to understand one by one, and for better understanding, I will show you one more graphical animation, and through that we'll try to understand the
example of the different levels of automation in a factory or industry. It also serves as a visual example of how technology is being integrated into industry. So let's take a closer look and try to break the pyramid down. Beginning on the bottom of the pyramid is what we will refer to as the field level. These are the devices, actuators, and sensors that you see in the field or on the production floor. If you think of it this way, the field level is the production floor that does the physical work and monitoring. Electric motors, hydraulic and pneumatic actuators to move machinery, proximity switches used to detect that movement or certain materials, photoelectric switches that detect similar things will all play a part in the field level. The next level is referred to as the control level. This is where the PLCs and PIDs come into play. The control level uses these devices to control and run the devices in the field level that actually do the physical work. They take in information from all of the sensors, switches, and other input devices to make decisions on what outputs to turn on to complete the programmed task. A PID is usually integrated into the PLC and stands for Proportional Integral Derivative. That is what can keep a variable within a set of parameters. A common example that you probably use every day is your cruise control. You set your cruise control to whatever speed you want, then a set of sensors and the computer in the car will tell it when to accelerate or decelerate according to the set speed. A common industrial PID-controlled item is a heater. Many systems in manufacturing plants have to be heated. We control this with a PID block within the PLC. When a set point is entered, the PID will determine when the PLC needs to turn the heater on and off to maintain a constant temperature. The third level of the automation pyramid is known as the supervisory level. Where the previous level utilizes PLCs, this level utilizes SCADA. SCADA is short for Supervisory Control and Data Acquisition. SCADA is essentially the combination of the previous levels used to access data and control systems from a single location. Plus, it usually adds a graphical user interface, or an HMI, to control functions remotely. Water plants will often employ this technology to control remote water pumps in their systems. The important thing to remember about SCADA is that it can monitor and control multiple systems from a single location. It isn't limited to a single machine like HMIs that we've discussed in previous videos. The fourth level of the automation pyramid is called the planning level. This level utilizes a computer management system known as MES, or Manufacturing Execution System. MES monitors the entire manufacturing process in a plant or factory from the raw materials to the finished product. This allows management to see exactly what is happening and allows them to make decisions based on that information. They can adjust raw material orders or shipment plans based on real data received from the systems we talked about earlier. The top of the pyramid is what is called the management level. This level uses the company's integrated management system, which is known as the ERP, or Enterprise Resource Planning. This is where a company's top management can see and control their operations. ERP is usually a suite of different computer applications that can see everything going on inside a company. It utilizes all of the previous levels of technology, plus some more software, to accomplish this level of integration. This allows the business to be able to monitor all levels of the business, from manufacturing to sales to purchasing to finance and payroll, plus many others. The integration of the ERP promotes efficiency and transparency within a company by keeping everyone on the same page. So let's see what you've learned about the automation pyramid. When you start at the bottom, you're starting on the production floor with all of the sensors, motors, and actuators that make the facility run. As you move up the pyramid, the next level is for controlling the field level. This is where the PLCs and PIDs come in to control the devices at the field level. The next level is the SCADA controls. These are great for controlling and automating large areas or over long distances. The last two levels are mostly for management, one to control a single plant, the last that can monitor an entire company inside and out. I truly hope this gave you a little information on the automation pyramid and how technology is automating industry.